Hello everyone, we're back again. For now, the 8th graders, this is the first lesson in chemistry and it's all about how to tell the difference between the physical and the chemical change. For an example here, I had some sort of ingredients, let's say like butter. Okay, as we all know that butter, when it's like a solid state, but sometimes when it's kept into the room temperature, it might go slightly to melt, and especially if it's like too hot outside, it will melt completely. This change from the state of being solid to liquid, it's actually called a physical change. Why? Because it's just the change from the physical part. Like the particles inside did not change. It did not change its color. It did not produce another substance, and it did not come out with a change in the energy. So practically, it's actually a physical change. And we can take it back. Like since it's liquid, I can just put it a bit in the freezer and it gets back into the solid state. So by here, it's a reversible change. So the physical change here is all about changing the original state, and it can be like reversing, and also the atoms and molecules inside of it won't change. Let's check over here the signs of a change. All changes of state are called physical change. That means it's like you've got the state of matter, the liquid, the gas, the solid. All those processes are actually considered to be a physical change, because the atoms and molecules within don't change. And all physical changes are reversible. That means I can take it back, which means the original state can be achieved by reversing the change. The nature of the atoms and the molecules are involved in a physical change is not altered. That means it doesn't change, it stays as it is. And a few physical changes, like for an example, dissolving. If I have sugar and I add it into water, it dissolves, and if I want to gain it back, I just wait until I can heat it up and wait for the water to evaporate, and then I'll have the crystals in between. So it's kind of like that's what we actually say, that it's a physical change. But most physical changes don't have energy exchange associated with them. Okay, then what happens for the chemical change? The chemical change here, if I have two substance reacting together, I would practically or 100% sure that I would have eventually a new product. So this is like one of the properties of chemical changes, that you can have a change in the color, you can have a new product as a production of a chemical reaction, and sometimes, depending on the reaction that you have, energy may be given as two types, exothermic or endothermic. Okay. The chemical changes are difficult to reverse. They occur as a result of a reaction between the reactant chemicals to make new products. They can be summarized by an equation. Okay, the chemical change has occurred may include the change of color, like here in the test tubes, and new substance may be formed that has a different state from the reactants. Like for an example, I have two substances reacting with each other, but the product, the final production that I got, is totally different from the reactants. It can happen because that's what chemical change is about. Like it's a solid formed two liquids, or a gas may be released from the reaction. And also they may be energy change, like energy can be given as an exothermic process, and it will be like a slight increase in temperature, or can taken in and the temperature decreases, and also energy transfers can also be caused by light. We've got here another type of changes, which is the ambiguous changes, which happens to be in between. Sometimes it has like the physical property, and sometimes it has like the chemical sort of change. So they show signs of both. As an example here, adding ammonium nitrate to water, it gives a marked temperature decrease. Marked temperature decrease, that means it's actually an endothermic process. However, the ammonium nitrate is just dissolving, so it's more likely as a physical change. If the mixture is heated, the salt can be recovered. It's a physical, but it has not changed chemically. But here, when we have energy as like an endothermic process, it's supposed to be chemical. So here, this whole process is actually in between. It shows both sides, the physical and the chemical change as well. An alloy, which is a combination of several metals, has a different physical properties from both of its components. This might lead you to believe that making an alloy is a chemical change, but however, the particles have not been changed. Like for brass, a type of an alloy is made of 60% of copper and 40% of zinc. So practically here, it has like the same properties of both components. The next lesson here is explaining the properties of mixtures. Okay, what is actually a mixture? It's like we have like two substances mixed together but not chemically joined. Like there's a lot of changes occur into a matter. For an example, there's something called boiling point, melting point, and each one of them like happens in a specific sort of temperature. Sorry for that. Okay. The pure water freezes at 0 Celsius degree, meanwhile it boils at 100 Celsius degree. If sodium chloride is added to liquid water, the temperature at which the water freezes and boils, it changes. Why? Because it's no longer pure water. It's actually been mixed with another substance. Okay, as we all know, like for an example, I'm making salad. And I want to like add a bit of salt and a bit of oil and some lime, squeeze a bit of lime to enable like to have a texture, have like a different flavor. But we all know that water is never mixed with oil. Why? Because it's like a different in density, and just oil doesn't happen to mix with water. Then if I want to like, if I had like a greasy sort of meal and oops, I dropped some of that food on my t-shirt, how would I be able to take it off? Does it does it just go away with scrubbing it with a bit of water? No, I have to use like sometimes soap and sometimes like a specific soap that contains enzymes to take away the grease. Why? Because oil does not dissolve in water like other substance. So here it comes the role of adding emulsifiers. Why? Because like emulsion is more likely as the mixture of two liquids. One is water-based and one is oil-based. Enable them to be emulsed or actually mixed with these two, with the nature of these two substances. Okay, an emulsion here is a mixture of two liquids. One is water-based and the other one is oil-based, which do not normally mix. So an emulsifier can be added to the mixture to change its properties. The emulsifier has a structure with water-loving and oil-loving end, so it has both. This is the property of it. It allows two different liquids to be in contact with each other and they become evenly spread. Because if I have like, I have this salad dressing, vinegar, oil, and something else, like anything. Okay, why do I have to shake it before I pour it? Because you will find out that the oil layer is on the top, then the other layers come like after it, because they don't actually mix. So when I add emulsifier, they go smoothly and they just happen to have a harmony in between. This is important quality in many food products like mayonnaise, milk, ice cream, and salad cream. Also in many other products like paint, moisturizing creams, butter, and margarine. Okay. Oops. Yep. Explaining colloids. When different states of matter are dispersed, mixed together, this is known as colloid. For an example, an aerosol, there may be particles of liquid or solid sprayed about in a gas. When an aerosol is sprayed, the gas particles here help to move the liquid to where they need to be applied. And the foam, like the ones that we get out of like those sort of like cream, whipped cream, and sometimes the foam, sometimes it's like more likely as a hair product or something like that. So it's practically a mixture of gas bubbles trapped inside a liquid blowing bubble. As an example, is like making a foam, especially for those who apply it on fires in order to just take it down. So yeah,